Hello and welcome to Unit A8. So that's the 8th algebra unit, and as you can see there, the title of this unit is Advanced Linear Graphs and Equations. As you'll have seen with a number of our other videos, we've got a number of objectives, so this is a fairly hefty unit with 10 separate objectives, and it's important that you work through each in order and tick them off as you go, as you've been told on other videos. So, just to start off with, some prior knowledge that's useful. A number of the previous algebra units are useful, but the two I've taken out, which I think are particularly useful for this unit, are A3 on linear equations, and as a reminder, that's where you learn to solve linear equations, and Unit A5, where you learn to, if you like, represent certain equations on the Cartesian grid with your x and y axes. So, moving on to our first objective. So to know how to find the gradient of a line, you see the steps there, which I won't keep repeating. So you've got 2 Corbett Maths videos to watch and then a number of questions to complete, and then finish with those Hegarty tasks. And it's important that you do things in order so that when you get to those tasks, we can see how you get on and your teacher will see where you have weaknesses and strengths. Just a quick reminder on gradients. Obviously those videos will go through how to calculate the actual gradients, but a reminder, the graph on the left there is an example of a positive gradient where it's going uphill, and on the right you have an example of a negative gradient. So just to remind you that positive gradients go uphill and negative gradients go downhill. The second objective is to know how to draw lines with equation y equals mx plus c. So again, the graph that we have at the bottom there, you'll see that the y-intercept is 3 because that's where it passes through the y-axis, and the gradient is every unit you increase in the y-axis for every unit on x. So you can see as you go across 1 on the x-axis, you go 2 up on the y-axis, so it has a gradient of 2. So you can put that together as the equation for that line. The red line you see in the graph will be y equals 2x plus 3. The third objective is to know how to find the equation of a line given its gradient and a point. And again, work through those tasks in order and then complete the Hegarty tasks at the end. So your teachers again can see where you have your strengths and your weaknesses. Now this is the first of our higher only objectives. So if you're doing the foundation GCSE, there's no need to worry about this objective here. And this is to know and identify parallel and perpendicular lines. And again, another higher topic is to know how to solve more complex problems with linear graphs. So again, those 3 tasks, self-explanatory, work through them in order, 1, 2 and 3. Now objective 6 is to know how to solve simultaneous equations graphically. Now this generally follows on in examinations once you have drawn the graphs first of all. So from a solving simultaneous equations point of view, it's very simple once you've got the graphs drawn, but obviously it's very time consuming, so it's not a method that you would particularly use if you didn't have to draw the graphs first of all. So if you look at the simultaneous equations, which I'll talk more about in the next couple of slides, simultaneous equations, as the word suggests, you are solving more than one equation at the same time. Now at GCSE, we're only ever looking at 2 linear equations at the moment, and I'll explain a little bit more about that in a moment. But you can see there you've got 2 equations, y minus 2x equals 14, and x plus y equals 8. So if I was to solve those equations graphically, I just identify the lines on the graph. So the first equation there, y minus 2x equals 14, you can see is the blue line on your diagram as it's labelled, and x plus y equals 8 is the green line. So if I was to solve them simultaneously, you just look at the coordinates of the point where they cross, and you can see that the blue and the green lines cross at the point minus 2, 10. So your solution to those simultaneous equations is your x value of minus 2 and a y value of 10. But, as I said, we need another method to do these. So, simultaneous equations, as we said, you're going to have 2 equations with 2 unknown values, x and y, and you have to find the values of x and y that satisfy both of those equations. Now, I've started off with that one because in some cases, in simple cases, you may be able to just see the answer with trial and error. So if you played around with numbers, say let x equals 2 in the first equation, then 3 times 2 is 6, so therefore y would have to be 4. But if you substitute that into the second equation, you can see that that wouldn't work. So the answer to this one is actually x is 3 and y equals 1. So just to clarify again, if we look at the first equation, 3 lots of 3 is 9, and then you add y, which is 1, so 9 plus 1 equals 10, so it works for the first equation. And then if you look at the second equation, you've got 2 lots of 3 is 6, and then 3 lots of 1 is 3, and 6 add 3 also equals 9. So you've solved your simultaneous equations. However, the problem with that method is that trial and error can take a long time, and what if you have negative and fractional solutions for x and y? So it really leads to the fact we need some proper methods that will work for obviously our harder equations, as I put them there, okay, and they'd obviously work for these as well. But I just hope using the trial and error gives you an idea of actually what we're trying to achieve. Now there are two methods that we can use. The first one is objective 7, so to know how to solve simultaneous equations by elimination. I would say at GCSE this is a very common method to solve two simultaneous equations. Okay, and you go through those tasks there and you'll learn how to use the method by elimination. The next objective, which is higher only again, is to know how to solve simultaneous equations by substitution. Now to be fair, at this point with two linear equations you might find that this method isn't terribly helpful, but I will say again at the end, when we look at a quadratic and a linear equation, then this method is the one that you would need to use. Okay, so as always in mathematics, for certain questions one topic will be easier than the other. However, we need to build up that armoury of all the different topics so we can apply the most efficient one to the question that we're given. So again, that's why we have objective 8 to solve simultaneous equations by substitution. So just to clarify, there are three methods. The graphical method, which is very simple, but it's very time consuming because you'd have to draw the graphs first. So you'd only use that when you've actually been asked to draw the graphs first, I would suggest. And then the next two methods, you have elimination, which is the most common when you have linear simultaneous equations, and then this method here to solve them by substitution. And then objective 9 is to know how to set up simultaneous equations in context. Now the interesting thing here is the actual solving of them you can often do by trial and error, but the test here is how you put a question like we have there into simultaneous equations to solve to find the solution. So in this question we have 2 cups and 3 plates costs £18, 5 cups and 1 plate costs £19. Okay, and the task is to find the cost of a cup and a plate. So first of all, we could let the cost of a cup be x, and then we can let the cost of a plate be y. Once we've set the cost of a cup to be x and the cost of a plate to be y, we can then set up two equations from the information that we're given. So the first one, 2 cups and 3 plates costs £18, can be written as the equation 2x plus 3y equals 18. And then we can set up the second equation from the second piece of information. So we've got 5 cups and 1 plate, so 5x plus y equals 19. Once you've set those up, as I said before, actually you can often solve these by trial and error, or use one of the methods that we've just discussed previously. So on that one I would suggest probably the elimination method will be the easiest. But again, by trial and error you can see hopefully that the cup would then be £3 and the plate would be £4. So again, in the first equation you can see 2 cups £6, 3 plates £12, 6 plus 12 does equal 18, and then the second equation, 5 lots of 3 is 15, plus the plate is 4, which also equals 19. So you can see you've solved for both equations. And then on to our final objective for this unit, A8. Again, this is a higher only topic, and it's to how to represent inequalities in two variables as a region on a graph. Now those obviously videos and questions will take you through it, but in brief, if we just look at this point here, you'll find in some textbooks that they shade the area that you want. So what we recommend is that you always shade the area that you don't want, and the reason for that will become clear in a moment, I hope. So on the left hand side there, you can see the line that's been drawn is y equals 2, and the region is the region below the line that we want, and that's labelled with an R, as you can see. So that inequality represents the values of y which are less than or equal to 2. Again, work through and you'll see all the bits and pieces that you need, but a solid line means that it can be less than or equal to, or greater than or equal to. Okay, you'll see on the right hand side we have another region there, and they're dotted lines. So that means that x in this diagram can be anywhere between the value of -3 and 4, but here they're dotted lines, which means they can't actually be on the line. So the inequality represented on the right hand side there is -3 is less than x, which is less than 4. Okay, so dotted lines for less than or greater than, solid lines for less than or equal to, and greater than or equal to. And as I said, why do we shade the area we don't want? Because the harder GCSE exam questions ask you to define the region that satisfies, in this case, 3 inequalities. Now it's much easier to find the area that hasn't been shaded at all than the area that's been shaded 3 times. Diagrams are an absolute mess if you shade the area you want. So that's why we shade the area we don't want, because as you can see on that example there, the region that satisfies all 3 conditions is very clearly not shaded in the middle. So that's your 10 objectives. As I say, really important topic. Okay, and for future knowledge, Unit A11 on quadratics 1 will start looking at quadratic graphs, and Unit A12 quadratics 2 is where we start looking at those simultaneous equations where one of your equations is a quadratic. So again, a lot of those topics are higher only, but we'll come to those units shortly. So good luck with all of those objectives. As I say, it's a hefty topic, and best of luck, and make sure you complete all the tasks in order so that we can then see how well you can do with your Hegarty tasks. Best of luck, everyone.